Nomenclature. In this video, our goals are going to be able to name both ionic and covalently bonded compounds, which of course means that we're first going to need to be able to identify which is ionic and which is covalent. So there's three types of bonding that we're going to have to deal with, and two that we'll be dealing with in this video and for most of class. And that is ionic and covalent. So ionic compounds trade electrons. So something like sodium chloride, where you have sodium giving an electron to chlorine, and then the two atoms, now charged, attracting each other. You also can have covalent compounds, where instead the molecules are sharing the atoms are sharing electrons with each other to form molecules. The way for right now that you'll be able to tell the difference between these is that ionic compounds are going to have a metal and a nonmetal bonded together, while covalent compounds are going to have all nonmetals. Now, this is actually a little bit of a simplification, and later on in the course we'll talk about how this is actually a bit of a gradient and some things have ionic and covalent character. For now, just use the metal and nonmetal versus nonmetal only definition. Something that we won't really be talking about, but you should be aware that exists, is metallic bonding, where we have delocalized electrons. Let's start with ionic naming. So for the positive ion, you're just going to give the name of the element. And for a negative ion, you're going to add an IDE to the ending. Positive ion goes first, negative ion goes second. This sounds a lot simpler than it is because we also have many polyatomic ions. And for those polyatomic ions, you're just going to give the name of them. However, they are very, very memory intensive as far as memorization goes. Here is a list that you need to know of all the polyatomics, and you need to know how to use them. Note that this is also available in the Naming Memorization Help document that I post online. You'll notice there's quite a few ions here, and this becomes very, very difficult very quickly. However, there is some helpful hints that you can do to make it so that you don't have to memorize all of them. So, for instance, with the 8s and the ites, the 8 endings and the ite endings, so for instance, sulfate and sulfite, vary by 1 oxygen. So if you memorize that sulfate as SO4 with a -2 charge, you would know that sulfite, ITE, is an SO3 with a -2 charge. This can help you out quite a bit. Per means to add an extra oxygen. Hypo means to take away another oxygen. I'll give you an example of this on the next slide.
And when we get to acids, we'll see that the ATE ending relates to the IC ending, and the ITE ending relates to the OUS ending. So for instance, sulfate would be sulfuric acid, sulfite would be turned into sulfurous acid.
As well as when we're talking about ions, such as iron, that have an old naming system, with ferrous and ferric, OUS, and IC. The IC is the one with the higher charge. So those are some memorization tips for you. Still a lot of memorization, still going to take some time, but it should help you out. That's for the polyatomics. For the charges, there's still some memorization that you must do. You can see the Memorization Help document for a list of all of those. Use the periodic table to help with your charges. Now let's do an example where I show you how this works. So let's say that I have memorized that ClO3 is chlorate. That's one thing to memorize. Now, if I want to know what the name of that acid is, I switch that ATE ending to IC. I added 1 hydrogen to balance the charges, which leaves me with chloric acid. That's using the rules for acid nomenclature. Now, let's use all the memorization tricks on the last page to see if we can work through some other names of ions. If I add another oxygen, that means that I already have one more, then I need to add another oxygen to a chlorate, so I need to add a PER prefix. That leaves me with perchlorate. If I want to switch that to an acid and add that hydrogen, now I need to use the rules for acids. So I switch the ATE ending to an IC ending, leaving me with perchloric acid. We already talked about ClO3. That was what we started with, what I had memorized. Now let's take away an oxygen. Now, if we take away an oxygen from something with an ATE ending, that leaves it with an ITE ending. So we go from chlorate to chlorite. When we use our acid nomenclature, anything with an ITE ending becomes an OUS ending, leaving us with chlorous acid. We take away one more oxygen, and then we need to add the hypo prefix. So we still have the ITE ending, but now we add a hypo prefix, so it's hypochlorite. Using our rules for acid, we switch the ITE ending to an OUS ending, and we have hypochlorous acid. Now let's do some practice with ionic nomenclature. So first, let's write the formula of things. Each time as we go through this, it's a good idea to stop, pause the video, try to do it on your own, see where you made your mistakes, and then see the answer. So first we have aluminum oxide. Now you need to know the charges of these in order to be able to make this. So you need to go and see that aluminum has a +3 charge and oxide has a -2 charge. If you're looking at this video and not understanding where I got that from, it is time to do some review on that. You can either look in your book or come visit me in office hours. So in order to make those charges balance out, we have to have 2 aluminums, so that there's +6 overall, and 3 oxygens, so that there's -6 overall, leaving us with Al2O3. Now let's do silver sulfate. First, silver has a +1 charge. That's one that you most likely at this point have to have memorized. Later on we'll learn exactly why that is. And then sulfate, a polyatomic ion that you need to have memorized as well. So we're going to need to have 2 silvers to balance out the charge of the 1 sulfate. Now we have magnesium cyanide. So if you look at your periodic table, you can see that magnesium would have a charge of +2. Cyanide is a polyatomic that you need to have memorized with a charge of -1, which means we need to balance it by having 2 cyanides. Now we use this nomenclature where we have the parentheses and the 2, and that allows you to tell that you have a cyanide ion. It's a lot simpler than putting C2N2, where you wouldn't really know if you had a polyatomic ion or some sort of covalent molecule. So please keep it with the parentheses, with the subscript. And then the last one, zinc oxide. Zinc has a charge of +2, oxygen has a charge of -2, so they balance each other out, yielding zinc, or ZnO. Now let's do it in the reverse. So we're going to write the name of FeCl2, and then we're also going to do FeCl3, so we can see the differences between them. So if we look at FeCl2, we can see that even though iron has 2 different oxidation states, and we need to figure out which one we're dealing with, since we know that chlorine has a -1 charge, that means in this case iron has to have a +2 charge. So we have iron 2 chloride. Now, we need to also remember that iron has 2 different forms of its name, and we can use the older style where we use ferrous or ferric. When you're using ferrous or ferric, the one with the lower charge has an OUS ending, so it's ferrous chloride. Something like ferrous 2 chloride, what I have here, should not be used. You either use the Roman numerals or you use this OUS ending on the older name. You don't use both. Now let's do FeCl3. Now because chlorine has a -1 charge, that means iron must have a +3 charge. So we'll have iron 3 chloride, and since this is the higher oxidation state, it's ferric chloride. So here we have RbSCN. This 2 shows is there because this has a negative charge as a whole ion. This has a +2 charge. So rubidium for the name of the element, and then you need to know the name of SCN. Sometimes you'll see this written as CSN too, and that is rubidium thiocyanate. Now let's do SnF2. So for here you have to know what Sn is. You can know several different things because there's 2 different ways of naming it. You could know that Sn is the name for tin, and because of the fluoride being there, it must be 10,2 fluoride. Or you can know that the base of that is stan, and because it's the lower charge, it is stannous fluoride. Stannous fluoride would also work. And then the last one, here we have sodium, and we have the phosphate ion combined with 3 sodiums because you need to have that to balance the charges, leaving us with sodium phosphate. So again, these are the polyatomic ions that you need to know. Make sure you learn these. They're in the Memorization Help document, so you can feel free to look at that whenever you need. The Memorization Help document also has all the ions that you need to know from the periodic table, all the metallic ions. So visit that for lists of what is required. Now let's do molecular compounds. So these are your covalently bonded, no metal compounds. The first word is going to have the prefix as above, if it's needed, and then the name of the compound, or the atom. However, mono isn't needed if there's only one. The second word is a prefix of above. The mono is required though, and you add an IDE as a suffix. Second word only. Those are your rules, and this one's a lot simpler actually. So let's go through and do some examples. Carbon monoxide. This is a good example where you can see that the first word is just the name of the element, and since there's only going to be one of them, you don't need to have the mono. It's just carbon. Meanwhile, the second word you do need the mono and is switched to an IDE ending. So it's going to be CO. Our next one is nitrogen trihydride. So we write that out. You have a nitrogen and then 3 H's. Keep in mind that's typically called ammonia. That's a common name for it. You'll find that lots of times we have common names for things rather than using the actual nomenclature. Next, sulfur dioxide. Again, notice there's no mono on the first word. It's not needed. So we have 1 sulfur and 2 oxygens, so SO2. Sulfur hexafluoride. 1 sulfur. The hexa is a 6, so it's SF6. So again, just memorize those 12 prefixes and you're pretty well set. Notice there is one trick that comes up when we have mono starting with an O. Because having 2 vowels together is a little strange, you drop the O from the mono. So it's monoxide. It's just the O from the oxide, no O from the mono. Now let's go in the reverse order. So here I have S2F10. So that's a disulfur. And then you look at what the prefix for 10 is, decafluoride. Disulfur decafluoride. We then end up with N2H4. So di again, so dinitrogen. Now you have 4 H's, so dinitrogen tetrahydride. pH3, 1 phosphorus. Remember not to include the mono, so it's just phosphorus, and then 3 hydrogens, so phosphorus trihydride. And then we have a phosphorus with 5 chlorines, so it's phosphorus pentachloride. Be very careful that you only use this for molecular compounds. You may not use this for ionic compounds, even though I know you want to. Be very careful about that. So now we've gone through, we've learned how to do all the nomenclature. You should go back, study this on your own, spend a lot of time with the memorization, and make sure that you know how to do this because you're going to need to be able to do this all through chemistry, and you're going to want to have it be second nature. You're not going to want to have to think about it too much. So spend a good amount of time doing this, even if it seems like rote memorization. It's actually one of the few places where memorization is very important. Make sure you know your polyatomic ions. Make sure you know how to combine ionic compounds together to make sure the charges are neutral. And be careful only to use the right nomenclature method. So use ionic nomenclature for ionic compounds and covalent nomenclature for covalent compounds.